Okay, so I want to complete this lesson that we started last time. So I want to start with this because my intention is to teach you something before solving this problem. Okay, first of all, let us actually follow what we learned in the previous lesson. Then I want you to feel why I want to change my strategy a little bit to solve this problem. Okay, the first part of it is of course as usual, because I told you that if you want to solve this polynomial equation, this is a hard problem because this is the fourth power polynomial, fourth degree polynomial, and solving polynomial equations with higher degrees is not that easy unless you can extract some piece of information from it. But the method that I told you here does not work for this probably. The coefficient, the divisors of 2 plus or minus 1, I haven't by the way checked that. The divisors are plus or minus 1, plus or minus 2. I don't know, I just wrote a question from a book, Mathematics 5000. So I didn't check if those numbers satisfy this equation or not. But in this case, I don't need it because they have given me that I is a root. Okay? So let us check that it is really a root. So that part is extremely simple. So we should be able to do that. So I need to calculate P of, for part 1, I have to calculate P of y and convince myself that P of y is indeed 0. So what should I do? I need to replace every appearance of z with I. So this becomes I to the 4th plus 2I to the 3rd. And then I have 3I squared, and then I have 2I, and then I have plus 2. So I have to convince myself that this is indeed 0. Okay, but that's very easy, yes, because I to power 2 is minus 1. I to power 4 becomes I to power 2 to the power of 2, which is minus 1 to the power of 2, which is 1. Yes. So if you don't mind, let me use that board as a scratch board. So I to the power of 4 is I to the power of 2 to the power of 2 is minus 1 to the power of 2 is 1. I to the power of 3 is I to the power of 2 times I. I to power 2 is minus 1, so it becomes minus I. Okay? So I put them back here. So this becomes 1 minus 2I. I squared is minus 1. 2I is just the same 2I. And then I have a 2. But it is not correct, is it?
Yes, it is.
Ah, yes, yes. 2I and 2I are gone. 2 plus 1, 3, minus 3 is 0. So that is indeed true. Yes? Okay. Okay, so now we want to go to the second part. So let us not change anything, follow exactly the lesson in the previous session. So what should I do now? You remember? Now I have one piece of information provided for me in the problem itself. I know something about this polynomial. I know I is a root, yes?
Long division.
Long division by what? I have to divide P of z by what? Z minus the number that they gave me, z minus I. This is the first time I am doing it in complex numbers, but the method is the same. Of course, let me test your understanding now here. So if I want to do this, I write z to the 4th plus 2z cubed, and then plus 3z squared, and then I have 2z and then plus 2. And then I divide this by z minus I using the long division. First of all, you will see that I will have some technical problems here. I mean computational problems. I have to be more careful because I will have I involved. Okay, but it is doable. I wanted to do it for you. But are you optimistic that this will work? Of course, definitely. If I am patient, I do the long division, then I will actually come up with a 0. So come up with a 0 remainder. And then if I write this one is equal to this one multiplied by the quotient, so I am able to factorize this polynomial. But why do you think this is I'm not saying this is bad, but I mean this is not as good as the examples we did yesterday. And you see why. So for example, you write P of Z equals to, if you do this long division, you get Z minus I times some quotient, which is still I don't know. And then definitely the remainder will be 0. So yes, I will have P of Z in factorized form. But then I want to solve P of Z equals to 0. Then I will face a little bit of problem again. Can you see why? Because if you put P of Z equal to 0, what is the conclusion? Either Z minus I is equal to 0, which of course is not surprising, gives you the root back, and then you will have Q of Z equals to 0. But this problem is still a hard problem. Why? Even if I still don't know Q of Z, I mean, this is still a little bit hard problem. The reason is, what is the degree of this? Yeah.
So the Q will be of the third degree.
A third degree again. So solving a third degree equation has its own problems again. Okay? Because we only can solve the first degree and the second degree equations very simple. But that is important to understand. Even without solving the problem, I know definitely Q of Z will be of degree 3. And then you will see that this becomes a little bit harder than usual, because then I will have probably complex coefficients involved. Because you know the coefficients of PZ are all real, and on the other hand you see an I here, so this means that some of these coefficients here should also be complex numbers, so that when i's are multiplied, i's are gone totally. So this means that this is not only a third degree polynomial, but it will be a third degree polynomial involving complex coefficients. So that's why, in principle, it's better to give up, not to follow this. That's what I'm telling. I want you to see that the same strategy I told you yesterday, I want still to follow that. But for this reason, I want to give up and find a new strategy. But just for practice, I want to do this long division together. Okay? It's just for practice. So because this is not the way that I want to solve the problem. But let us see that how it works. I'm just practicing for long division method. So I take the first term divided by the first term, I put it here, Z cubed, multiply this here, and then write it with the opposite sign here. So this becomes minus Z4. The next one becomes minus IZ cubed, but I write it as positive IZ cubed. Yes? And then I start adding them up, then you understand what the problem is. Because this one and that one are cancelled, these two are similar, so I have to add them up. But how should I add them? That is 2, that is I. So I have to write 2 plus I times Z cubed. Okay, so the coefficient becomes a little bit more complicated. Plus Z squared. Again, let me emphasize, I'm not solving the problem using this. This is just for practice about long division with complex coefficients. And if you see I'm doing a mistake, please just shout so that I can fix it before being a mess. Okay, that's correct. Okay, then I have to do the process once more. So I take this one and multiply it by the first term. What do I get? I get this expression with second power of Z. So I put it here. So it becomes 2 plus I Z squared. And then when I multiply this there and change the sign, it becomes minus 2 plus IZ cubed. The next one becomes negative I times that. I change the sign, it becomes positive I times this Z squared. And then what I do, I will get rid of them. But then again, Z squared and Z squared. So let me go to scratch paper. The coefficient of that Z squared is 3. The coefficient of the other Z squared down there is I times 2 plus I. So this becomes 3 plus 2I. I times I is minus 1, so it becomes 2 plus 2I. Yes? That is 2 plus 2I. So when I add this one to that one, it becomes 2 plus 2I Z squared and then 2z, and 2 comes down. I repeat the process. I divide this in my head by z, it becomes plus 2 plus 2i z. I multiply this and then change the sign. I multiply this by the other one and change the sign. And then I add them up again. And these two are cancelled. Again, I go to a scratch paper. The coefficient there is 2. The coefficient of the other one is I times 2 plus 2i. I multiply this in, so it becomes 2 plus 2i minus 2, so it becomes 2i. So if I add these two, it becomes 2i. So it becomes 2iz plus 2. And hopefully, if I have done everything right, that would be the last step, and I will get probably the 0 remainder. Otherwise, I have made a mistake because we confirmed that I is indeed a root. So the remainder has to be 0. So I take this one and divide it by z, it becomes 2i. And then I multiply 2i there, change the sign, it becomes minus 2iz. I multiply 2i by minus I, so 2i by minus I, it becomes minus 2i squared, it becomes positive 2. But when I want to remove it there, I have to change the sign. And then our prediction was correct, the remainder is 0. So you see, it was possible, but it is not promising if I want to solve that one. Yes, because now I can go back to my scratch paper. Now I know what Q of Z is. And our prediction was right. Q of Z is not only of degree 3, but some of the coefficients are also complex numbers. So in principle, the problem is still standing. Even though I succeeded to factorize that, but Q of Z is that long expression top there. So I have to make sure that I know how to solve this problem. Let me factor a 2 out. Okay, which is not that simple. So, to be honest, we did nothing. Because I already knew that I is an answer. Finding the other answers, I have to solve this equation, which is even probably harder than the original equation because of having complex coefficients as well. Yes? Okay, so at least I wanted to do this because I wanted to practice about this long division with complex numbers as well. But now I hope that you are motivated to change your strategy. Okay. So now I want to use a theorem. I want to understand. Any questions here? So this original method of solving failed. Yes? We want to find a different way. Okay, so let me put it in the scratch work. Let me ask your opinion about that. Okay, so let us consider this polynomial. Let me consider it Q of Z. I write Z to the power of 5. Let me write it like this. 7Z to the power of 5. And then minus 2Z to the power of 2 plus Z minus 1. I give you this polynomial. Okay, and I tell you that someone told me that Z naught is a root of this equation. Okay? And then my question is that by this piece of information, you can immediately find a second root, not the second root. Because you know that this, in complex numbers, including multiplicities, has exactly 5 roots. Let us say one of those 5 roots is Z naught. I want to ask, as soon as you get one of the roots, you can immediately know the second one, a second one. What is that one? Any ideas? Yes?
Negative.
What?
Negative.
No, negative does not work. We can check. If so, for example, when you say Q naught is 0, so Z naught is the root, it means Q Z naught is 0. Yes, this is what you know. Yes. So when I write 7z naught to power 5 minus 2z naught to power 2 plus z naught minus 1, you said negative z naught. Let us check. If I write q minus z naught, it becomes equal to, this becomes minus 7z naught to power 5, this becomes minus 2z naught squared, this becomes minus z naught, and then this becomes minus 1. Okay. If this is granted to be 0, you cannot still grant that this one is also 0. Yes? Because what is the relation here? I have to make them the same, so let me factor a minus sign out, then it becomes 7z naught 5 plus, unfortunately, 2z naught squared, and then I will have plus z naught plus 1. So if this is granted to be 0, there is no guarantee that this one is also 0, yes? So this should be minus. No. Yeah, so that's correct. Yeah. So your guess was not that bad, but it didn't work. I hope that I could convince you. Are you convinced that this, there is no guarantee unless you are lucky and all these powers are odd. If all those powers are odd, yes. If z naught is a root, minus z naught is also a root. But it doesn't work in this case. I didn't, by the way, think about this, so I was lucky that I just chose one of them to be even. Yes.
I have a question. You said that if z had a negative power, an odd power, it would work with negative. But doesn't that mean there also has, the constant can't exist because the constant is not affected?
Yes, you're right. Yes. So there are two conditions. The constant should be 0, and you're right. Anyway, so that is not the answer. But what I want you is something similar to this guess. If z naught is a root, we cannot be sure that minus z naught is a root. But we can be sure that, can you tell me? Z naught bar is a root. Okay, so that is the guess. Okay, let us double check that. Of course, the proof is exactly the same for the general case. I hope that when I tell you the proof, you are convinced that this is indeed the case. So this is granted to be a root. I want to confirm that this is indeed a root always. Why is that? Okay, when you say z naught is a root, it means that, so z naught is a root. So this means that q z naught is 0. This means that 7z naught to the 5th minus 2z naught squared plus z naught minus 1 is 0. Okay, but now if this complex number is 0, its conjugate remains 0. The conjugate of this should be equal to the conjugate of this. If these two complex numbers are equal, the conjugates are also equal. But the conjugate of 0 is 0, we know. But what can I write for the conjugate of this polynomial? We had a lot of properties, I hope that you haven't forgotten. One property was that if I have z plus w, and then I want to take the conjugate, I am allowed to take the conjugate of z, the conjugate of w, then add them up. So the same thing is true for subtraction. The same thing is true for multiplication and division. Division is not needed here, so let me write multiplication. So we had these two rules before. And then we also use this rule to write z to the n bar is equal to z bar to the n if n is a natural number. So these rules, I hope that you remember at least. We studied them. So I can use these three rules to write this in a different way. I have the difference and the sum of a bunch of complex numbers, and I am interested in the conjugate of the total one. So it becomes the conjugate of the first part minus the conjugate of the second part plus the conjugate of the third part minus the conjugate of the last part. Yes? But what can I do here? This is a product, so it becomes the conjugate of 7. I intentionally want to write them. Z naught 5 conjugate minus 2 bar z naught squared conjugate, z naught conjugate minus. What can I write for 1 bar? The conjugate of 1 is just 1. On the other hand, I have 0. Okay, the next step. 7 bar is just simply 7. And according to this rule, I can interchange the conjugation and power. So it becomes z naught bar to the power of 5. This one becomes minus 2 z naught bar to the power of 2. This remains the same, and this becomes minus 1 equals to 0. But if I ask you what is this in terms of polynomial q, so this is q of what? This was q of z, yes? So this is q of what?
C bar.
Z naught bar, yes? So this is q of z naught bar is equal to 0. So I am done. So if z naught is a root, I am allowed to conclude this, and using those properties, I realize that z naught bar satisfies the same polynomial. Yes? So it means that if z naught is a root of this equation, z naught bar is definitely a root of that equation. This is not useful if you have a real root, because if z naught is real, z naught bar is the same. But in this case, it is different, because one root is I, definitely the other root is minus I in this case, yes? Because I bar is minus I. But can you tell me, is this idea valid for all polynomials or a class of polynomials?
Which one would you?
Yes?
I would expect it with polynomials.
Not all polynomials. Because all polynomials in the set of complex numbers, this is also a polynomial.
Yeah.
But this does not work for this.
Does it not?
No. Why not?
Bar thing.
Because you see, 7 bar is still 7.
Yeah.
2 bar is still 2. Okay? But here, this coefficient is not real. So its bar becomes 2 minus I, and it will not give this rise to the same polynomial. So, I want to say it orally, but if you want, you can write it somewhere. So we can say that, let me write it down because it's important. Let P of z be a polynomial with, what should I write? With we just learned it is not
With a
working for
real
all.
coefficient.
With real coefficients. With real coefficients. And let z naught be a complex root of P of z. Then z naught bar is also a root of P of z. So that's a very important remark. It's a little bit of game changer in this problem. Okay, so if you don't mind, because that failed, that method failed, I clean it, and now I ask your opinion about, do you have an alternative way to solve this problem? A combination of what I told you now and what we did last time. Okay, so let me clean this. It was a good exercise in doing long division, but it was not useful. Okay, first of all, tell me, is this remark applicable for this polynomial? Yes, because the coefficients are all real. Okay, so now we checked that the complex number I is a root of this polynomial. Yes? based on that remark, I immediately know another root. The other root is I bar, okay? Which is minus I. So the other root, so part 2, another root, another root is I bar is minus I. Okay, so because I is a root, this is divisible by z minus I. Yes? Now that I know that minus I is a root, what can I say?
So it's divisible by
P, so it is divisible by
C plus I.
z plus I. So I learned that P of z is divisible by z minus I because I is a root. Because of this remark, I realized that I bar, in this case minus I, is also a root. So it means that definitely my polynomial is also divisible by z minus that number, which becomes plus I. And now, because these polynomials are relatively
Wait.
prime, they don't have, yes?
Wait, so you're saying that C. We're saying that. Wait, what are we saying?
We are saying that,
For what did you
so,
say?
so if I have if A is a root of my polynomial, what can I conclude? I can conclude x minus A is a factor. Yes?
Yes.
So now if I say minus A is a root of polynomial, what is the factor then? The factor is x minus A. Yes? So which becomes x plus A. I'm saying this.
Yes.
So I is a root. My polynomial has a factor of z minus I. Minus I is also a root. It has this factor as well. So I don't understand what's the hard part.
No, I thought we said that 2 should be divisible, but I
No.
just
So we have these two roots. We have these two factors. Now my polynomial P of z is divisible by this on the one hand. It's divisible by this on the other hand. But these two are relatively prime polynomials, meaning that they don't have any other factors involved in common. So what can I conclude?
There has to be another factor involved.
No, their product is.
No, might be there are some. Yes, there are some factors involved, but
The polynomial is divisible by their product.
the product. Yes, if a polynomial. So do you remember if a number is divisible by 2 and it's divisible by 3, because 2 and 3 are relatively prime, I can conclude my number is divisible by the product 6. So now my polynomial P of z is divisible by this and that. They are relatively prime. They don't have any other non-trivial factor in common. So I can say that P of z is divisible by what? By the product z minus I times z plus I. Yes? But this is simple. What is this? It becomes z squared minus I squared, which becomes z squared plus 1. Yes? So I know that just by one piece of information and using that remark, I can understand that my polynomial is divisible by z squared plus 1. Yes?
But why do we know for certain that they are relatively prime?
No, because this is a first degree polynomial. How can you factorize a first degree polynomial? At most you can factorize it by a number multiplied by that. Yes?
Yeah. But like.
But you're asking strange questions now.
But no, but if C.
So x and x minus 3 as a polynomial, they are relatively prime. If they are not relatively prime, it means there is another polynomial involving x that divides both of them.
No, okay.
Yes, that's the meaning, yes. Okay, so P of z is divisible by the product. So what should I do now? Do you think that this really can solve my problem now?
Yes.
Why? Because this time I take my P of z and then divide it by z squared plus 1. Again, I will have a quotient, but this quotient is manageable now. Why? Because then this is of 4th degree, this is of 2nd degree, so this has to also be of 2nd degree, and the 2nd degree is manageable for us. So you see that this was important. I want to use this example to teach you this idea. Okay, now we start doing this. And then the rest of it is as simple as before. So let us just do it very fast. 3z squared plus 2z plus 2, and then I divide this time by z squared plus 1 instead. Okay, the first one divided by the first one, z squared, multiply and change the sign. Okay, another important thing to be careful, this is minus z squared is similar to that one, so this is left alone, but because the degree is higher, you have to respect the order and bring this one first. But this one will be absorbed to that one, so I will get 2z squared. The leftovers are these two, I bring them. Yes? I continue the process. I divide this by that, so it becomes 2z. I multiply that there, so it becomes minus 2z cubed. I'm changing the sign as well. And again, look, this is not similar to this one. This one will cancel that one. These two, I bring them down. And I do the process once more, then I am done. So it becomes 2. It becomes minus 2z squared minus 2. And as I expected, the remainder is 0. Yes? Okay, so what should we do? We just write my polynomial p of z now is this one multiplied by the quotient plus the remainder is 0, so I have the factorized form. And I am supposed to find the roots, so p of z, I put it equal to 0, then I will get two options. Either this one is 0, which is not surprising, because if I solve it, I know what I get. Z squared is minus 1, what do I get? Z is plus or minus I. It becomes plus or minus the square root of minus 1, square root of minus 1 is I. But of course, it is not surprising, I already knew the answers. So this is the one that I didn't know. Okay, because this is even, let me use PQ formula this time. So this one divided by 2 with the minus sign plus or minus this one to power 2 minus Q. So this becomes minus 1 plus or minus the square root of minus 1, which is minus 1 plus or minus I. So the roots that I didn't know about are these two. So they gave me one of the roots. I got 3 of them myself. One of them using the remark, 2 of them using the long division. Yes?
Do we even need to say that the c minus 1 and c plus 1 are like relatively prime?
Yes.
Because can't we...
No, I want you to understand that. You don't need to write it down. But
yeah, but
because if I have something divisible by x minus
yes,
1
of course.
and x2 minus 1, no. So let me see. X minus 1 and x3 minus 1. Yes? No, even x2 minus 1 is good. If something is divisible by x minus 1 and x2 minus 1 simultaneously, there is no guarantee that this is divisible by the product.
But since we said that both I and negative I are roots for equation, I'm not sure how to formally say it, but isn't it guaranteed that we then can write our original polynomial as the product of x or c minus first root times c minus?
No, you are thinking about
times.
No, I am just referring to a theorem because I am claiming something. I'm saying that because p of z is divisible by these two, I am claiming that p of z should be divisible by the product as well.
Yeah.
And if I want to use it in this way, I have to convince myself that these are relatively prime. But because these are degree 1 polynomials, they're always relatively prime if they are not the same.
But like, aren't we already guaranteed this since, or that it is divisible by the product of them since you're both, or they're not roots directly, but...
Yes, I understand what you mean. Yes, in that context, that's also correct.
Okay.
Yes, because if I know that I is a root minus I is a root, then definitely z minus I will be in my factors. z plus I will also be in my factors.
Yeah.
And then both of them appear, it means that I see the product there. Yes, you are right.
Okay.
Yes. Okay, so this was a good problem. The old version, Mathematics 5000, I am taking these examples from there. I think they are good examples. Okay, so let me give you a similar one, but a little bit more complicated, computationally involved. Okay, so let me see. What I want to do, I want to change the polynomial. Because here I don't have the pausing option. I don't know, should I wait for you to solve it or we can solve it together? So P of z, this time is this, z to the fourth minus 2z cubed and then plus z squared plus 2z and then minus 2. Let me double check. Z to the fourth 2, yes. That's correct. Show that 1 plus I, it's the same problem, but computationally a little bit more involved. Show that 1 plus I is a root of this polynomial. Solve the equation P of z equals to 0. Okay. So I don't know if so let me stop I can glue the videos, but of course that would be, I don't like these things, but anyway. I don't know why they don't put a pause damn button there. Yes. Okay, so let us solve this one because there are some other problems that I want to finalize today. Show that this is a root, so this is not hard. So part 1, I have to convince myself that P1 plus I is actually 0. So I go here, replace z with this expression. Yes? In order to answer this question, I have to simplify these three. Let me start with the simplest one. 1 plus I squared is very simple. The first one squared 2 times the first one times the second one plus the second one squared. But I squared fortunately becomes -1, cancel that one, so I will get 2i. But then if I want to have 1 plus I to the third power, what I will do, I will write it as 1 plus I to the second power times 1 plus I. For the second power, I got 2i. 1 plus I, so it becomes 2i minus 2, because 2i squared is minus 2. And then finally, I plus I to the power of 4 is 1 plus I to the power of 2, again to the power of 2. Yes? But 1 plus I to power 2 is 2i, to the power of 2, to the power of 2 is 4i squared is minus 1. Okay, so therefore P of 1 plus I is equal to, the first one is minus 4, the second one is minus 2 times 1 plus 2 times 2i minus 2, the next one is 2i, the next one is I multiply 2 in, and then finally minus 2. Simplify one more step, minus 4i plus 4 plus 2i plus 2 plus 2i minus 2. So 2i, 4i minus 4i are gone, 4 minus 4 are gone, 2 and minus 2, yes, that's correct. So anyway, I'm not saying that you have to do it in that way, anyway you have done it, the answer becomes 0. So this confirms that 1 plus I is a root. For the same scenario as I told you before, if you just immediately jump to divide this by what? If you want to divide, what you divide by? No, first of all, let us say I want to naively start to divide. So I divide this by what expression? What?
Or
Z minus.
Z minus the whole 1 plus I. Okay? But that's not a good idea for the same reason. But now this is a polynomial with real coefficients. 1 plus I is a root. So P of z is a polynomial with real coefficients. thus 1 minus I is also 1 plus I bar, which is 1 minus I, is also a root. Is also a root. So this means that on the one hand, my polynomial is divisible by this combination. On the other hand, my polynomial is divisible by that combination. So it means that my polynomial will be divisible by the product. Yes? Okay, so let us do this product. So z times z is z squared. Z times this number is minus 1 times z. This times that. And then minus minus plus 1 plus I, 1 minus I. I have to simplify that.
Like this, you can just do
So what happens? This becomes z squared. Between these two, I factor a minus z out. 1 minus I is left from here, 1 plus I is left from there. And here, this is the conjugate rule. If you want, let me write 1 squared minus I squared. But then I and I are gone. This becomes 2, so it becomes z squared minus 2z, and this also becomes 2. So I realize that my polynomial is actually divisible by this polynomial. I do the long division here, so z to the 4th minus 2z cubed plus z squared plus 2z minus 2. I divide this by this polynomial. This is the first time that my divisor polynomial has more than 2 terms. Yes? So then this one to that one is z squared. I multiply, change the sign.
Wait, how do you solve, like, what is the general rule? Because we do, or is it just that we, I don't know, but because we need to divide c, the first term, or the
No,
first.
always the first term by the first term. It doesn't matter how many terms you have here.
Okay, it's always like that.
Yes, always.
Okay.
Yes.
That's, I hadn't heard that.
Yeah.
That part.
And that's what I'm saying. This is the first time that we have more than 2 terms in the divisor. It's always the first and the first. Okay? So now minus z to the power of 4 minus, yes. So z 4 minus, this is minus, I make it positive. This is plus, I make it negative. And then this one and that one are gone. Oh, here this one and that one are also gone. But then this one with that one becomes minus z squared plus 2z minus 2. Oh, it was much simpler than I thought. There's one more step, yes? You divide this by that, it becomes minus 1. You multiply minus back here and then change the sign. So minus z squared, you write z squared, plus 2z squared, plus 2z, you write minus 2z, minus 2, you write plus 2. And as we expected, the remainder is 0. Okay, so this means that my polynomial p of z is now factorized. This expression multiplied by that expression, z squared minus 1 multiplied by z squared minus 2z plus 2. So this means that p of z equals to 0. What happens? Then it means that either z squared minus 1 is 0 or z squared minus 2z plus 2 is 0. So what is the answer from here? Z squared is 1. So what is z? Z is simply plus or minus 1. Okay? So they have designed a question which was not very good, to be honest. You know that. I followed what they told. But in principle, let me tell you. Let me test your understanding. If I solve this equation, what do you think that I will get?
1 plus I and
1 minus I. Because we already checked that these two should be solutions. The answer to this is plus or minus 1. So definitely if you solve this, you should get those two roots back. And then I am sure you will do. So it becomes 1 plus or minus I. Okay? But this we already knew about it. These are the new ones. So that's why I'm saying this is not a good design question. Yes? Because if I have given you this from the beginning, might be, and without any informations, what do? You check out the divisors of minus 2. And the divisors of minus 2, one of them is minus 1, the other one is 1. So you really didn't need to go through this process. But it is better. I mean, at least you understand that this is going to work.
So do you think that's what they intended when they made the question, that they should do that?
Yeah, but of course in this problem we have to check this one because this is in the problem. But you can say that I don't want to use it, I want to follow my own method. That's also possible. Yes. So definitely if you put 1 and minus 1 here, it works. Yes, because we got the solutions. Okay. But one thing, let us try to solve some sample problems. Any questions here? Yes?
Or if I understood from yesterday,
Yes.
a complex number with the, in this case, 4th degree,
Yes.
to the 4th degree should have 4 roots.
Yes.
And we only have,
We have 4 roots. Plus or minus 1, 1 plus or minus.
oh, sorry.
No, but be careful. This doesn't mean 4 roots are distinct. So if I get plus or minus, let us say that I get 1 plus or minus I and only 1, for example.
Mhm.
Then it means that this is not a violation. You say that, okay, this is 4th degree, but Bob, like you got 3 numbers. Yes, I got 3 numbers, but it means that the multiplicity of one of them is 2. So in total, containing the multiplicities should be 4.
And plus and minus 1 are complex numbers. Or could be viewed as, or
Yeah, they can also be viewed as complex numbers or real numbers. It doesn't matter.
Okay.
Yes, so for example, by looking this, if I want to fully factorize my polynomial, in this case, this means P of Z. If I say factorize, that's a good question. If I ask you factorize this polynomial, but you are allowed to use the complex numbers, so then what do? You write Z minus one of them, Z minus the other one, Z minus this one, and Z minus that. This is the factorized form, the fully factorized form of my polynomial if I am allowed to use the complex numbers. But if I ask you, no, you are not allowed to factorize up to complex numbers, then this is still allowed, this is still allowed, but then I have to multiply them. And when I multiply them, I get this back. So the idea of factorization is that on which field you want to factorize.
No.
Field, I mean the domain of factorization. Here, the domain of factorization is C. You shouldn't stop here. What I'm saying is that if you are allowed to work on C, your factorization will be only 1st degree polynomials. Okay? But it might happen that 2 roots are the same, then you have 1 degree polynomial to power 2. Something like that. But if you are not allowed to work with complex numbers, it is not already guaranteed that you can factorize up to 1st degree. But it is guaranteed it would be a mixture of 1st degree or at most 2nd degree. Yes? I don't know if I answered your question or I answered a different question. Yes? Is that clear?
yes.
Yes? Okay. Yes?
So can you call a complex number a prime number? Like if it's
No.
I mean,
No, complex number and prime numbers are different entities.
no,
yes?
no. But for example, in this case, 1 minus I and 1 plus I would be prime. Yes, but like
No, there is no guessing. Why 1 plus I should be a prime? Because I can divide it by 1 minus I. Then it becomes a number.
Oh.
Then I have to consider integers in the realm of complex numbers. We don't have
but
those
if
things.
we did have a complex number which was not divisible by anything except itself, and 1.
No, what is the meaning of divisibility? We haven't defined divisibility
Oh.
in the first place. When 2 complex numbers, one of them is divisible by the other. Even divisibility is not defined for real numbers. we cannot say that the square root of 2 and the square root of 3 are divisible or not. Divisibility is exactly one of the properties that we learn for the integers. That's exactly this
But is there a
idea.
definition for it?
No, because it is useless. Because when you say that this number 6 is divisible by 2, it means there is another integer, so that multiplied by 2 becomes 6. But in the case of real numbers, I can say square root of 2 is divisible by square root of 3. Why? Because if you multiply the square root of 3 by square root of 2 over square root of 3, it becomes square root of 2, and this is real. So in that case, every real number is divisible by every other real number. Unless you want to define something in your own, you might say that, okay, I want to keep the quotient integer, but I want to talk about these two.
And is it the
But
same
I
as
haven't-
for complex number?
Yeah, you can probably do that, but that's exactly the same thing. If I divide two complex numbers, it's another complex number.
Yeah.
And that complex number multiplied by that, it becomes a numerator.
Yeah.
Yes? I mean, this question, what you're asking is not related to complex numbers. You could have asked this for the real numbers. And
Yeah.
if you are okay with this, then you can also be okay with this.
Yeah.
Yes? Okay, so now let me ask you some questions. Okay, first of all, do you remember, I gave you an example of a method of undetermined coefficient, which was not easy, but the situation is not so dark sometimes. For example, I just wrote one example here. I hope that this will work. Yes, for example, you don't need it at all, but I just want you to see it once. So let us say that I give you a polynomial, and I want you to factorize this. You can factorize it now. What is the, if I give you this and ask you factorize it, what is the method that you use?
Start with the
Yeah, but here, of course, there are a lot of them, but it is not hard. Yes, I mean, what are they?
6.
1 plus or minus 1, plus or minus 2, plus or minus 6. You start probably checking one of them, and if it works, then you divide this by x minus that number by long division.
Shouldn't 3 also be there?
Yeah, plus or minus 3 as well. Yes, thank you. So this becomes, but you don't need to be worried. For example, you start with the small numbers. But yes, in the worst case scenario, you have to check all these numbers, 8 numbers. Okay? But let us say that I want to do it with method of undetermined coefficients. So what can I say? I can say if I succeed to factorize this, at least I should have 2 factors, at least, or even sometimes 3 factors. But if I have at least 2 factors, then one factor should be what? A first degree, and the other one should be a second degree. Yes? By the way, in the method of undetermined coefficients, you don't need to disturb yourself, yes? It is already clear that these coefficients should be 1. Yes? Because if I multiply this by that, it will give me the third power. And I already know that the third power coefficient is 1. So this is the only way, if I want to factorize it in the realm of integers, of course. So I will not start with the most complicated scenario. I already know that these coefficients should be 1. And then I will do the same thing. So I will multiply it, so it becomes x cubed plus bx squared plus cx plus ax squared plus what? abx plus ac. And then organize it. X cubed, I have 2x squared, I factor it out. And then I have 2 x's, I factor it out, and then AC. Can you confirm my calculations? Let me double check, seems correct. And now I compare this one with this one. I don't have any problems with the third powers, they're already fixed. But in order this one to be this one for all choices of x, the coefficient of x squared b plus a should match with the coefficient of x squared there. And the coefficient of x should work with that coefficient, and this coefficient should also be minus 6. At least I have 3 equations in 3 unknowns. But still, I hope that you see it is not that obvious how to solve it, because this is not a standard. Even though I already decided about these 2 coefficients, but it's still, it is not that a straightforward question. So let us try to solve the system. I want you to feel that really method of long division is much better than the method of undetermined coefficients for this purpose. Yes? Because there is no way that I can start with simpler ideas. I would say that if it is going to be factorized, there should be at least 2 factors. If there are 2 factors, one of them should be first degree, the other one should be the second degree. It might happen that the second degree is also being factorized more, but we don't need to be worried about that now. And because this coefficient is 1, I already chose these coefficients to be 1, but still I have a system to solve. Okay, do you have any idea how to solve the system here?
Well, you just eliminate.
Eliminate. For example, I don't know, let us do randomly. For example, let me just eliminate B in favor of A. So it becomes minus 6 minus A. I put it here and I put it only here. So this becomes C plus A times minus 6 minus A is equal to 11.
Just because of third degree.
Yes, this is a very strange thing. I didn't expect this. Do you see what happens now? I go back to the same equation equal to 0.
Oh.
This is my guess. Let us see. Let us see how it works. But it shouldn't be that stupid.
No, it does become that.
Yeah, it becomes, I think.
Yeah.
So, so then it means that method of bounded. I need to see the example in the book because they actually gave an example that was working. But let us treat.
If you did the
Let us see.
opposite,
Might be my guess is wrong, but I
or,
think
or
that.
if you keep A instead, or switch A and B in the first.
No, that doesn't matter.
Okay, and then do what? Then what? So let me, for example, this is not probably working because what happens? C becomes minus 6A. I move to the other side. Minus A squared. I move to the other side, and that's 11. And then when I put it here, what happens? A multiplied by that, it becomes 6A squared plus A cubed plus 11A is equal to minus 6. Oh,
No, it's different.
it's a different one, but this is still hard to solve.
But it's very similar.
It's very similar, but I mean, there is no point for solving this because this is also the third degree polynomial. Be careful, I don't want to use, I can solve it but using the long division, but the whole point is that not to use the long division. So that was very strange for me.
But if you put A equal in the first one, if you put A equals to minus 6 minus B,
But then
A,
you can't
so let
eliminate.
us see what happens, let us follow this.
looking
So
at
what
the,
you are saying is that put A what?
system.
You mean this? And then what? And then put it here, multiplied by minus C. Let us see. It becomes minus 6, so I change these signs.
No, it doesn't.
And then what happens? Then I have to put this one there, so that becomes C. And then I multiply it by B, so it becomes minus 6B plus B squared is equal to 11. Do you have the book with you? I want to see which example they have used. I think this shouldn't be. So the system, of course you know that, by the way, you don't have to solve the system because you just want to guess these numbers, okay? But that is not good because if I want to guess, I could guess from the beginning. I would say that might be, we don't have that much options. This is why I want to see what they have done in the book. Let's see. Because we cannot simplify this more than that, yes? Can I? There should be, I remember there was an example. Okay. Oh, this is also very similar. Ah, okay. So they have already used 2 methods. Okay, so that's what I'm saying. If you want to start from scratch, so they are guessing 1 root is 2. Okay? So they are actually using this trick somehow to find one of the answers. And then when A is already found, then of course you can reduce your A, and the system becomes a standard. Yes. So what I'm saying is that what they are doing is not using the method of undetermined coefficients from scratch. They are combining this trick to get one piece of information for my equation, but instead of finding this using long division, they are using method of undetermined coefficients to factorize. Okay? So that was my impression. So that was a little bit strange to me. So because the solving this system goes back to more or less the same equation or a very similar equation. Okay? So what they have done in the book, and it is successful, is because they are saying that, okay, let us check one of these numbers. Which one of the numbers work, do you think? I think 1 works, yes? Because 1 plus 11 is 12, and that is also minus 12. So 1 works. And instead of writing it in this form, they say that because 1 works, then it is x minus 1 multiplied by x squared plus bx plus c. And then use method of undetermined coefficients just to determine these two. Which is of course much simpler, because now if I multiply, it becomes x cubed plus bx squared plus cx minus x squared minus bx minus c. And then it becomes x squared plus b minus 1 x squared, and then I have c minus bx minus c, and I compare it with that one. B minus 1 is minus 6, c minus b is 11, and minus c is minus 6. So from here, immediately you see that c is 6. If c is 6, what is b? It's minus 5. In both cases, b is minus 5. So then you put it back here, it becomes x minus 1, x squared minus 5x plus 6. Okay, so let me correct myself. So they are using that to extract one piece of information, but instead of doing long division to find the other factor, they are using the method of undetermined coefficient for the second factor. Yeah, so that was good. That was good for me to refresh my memory, because if you want to solve from scratch, you go back to a similar degree of difficulty equation. Yes? So that was the logic. Okay, before ending the lesson, so when the lesson ends, in how many minutes we have? We have 15 minutes. So let me tell you something that's also good to know. Okay, so my question is, I give you a polynomial. Let me start with some examples. I give you a polynomial, something like this: z to the power of 50 minus 2z cubed plus a z squared minus 2z plus 1. Okay, and I ask you to find the remainder of this polynomial by z minus 1. Okay. It is not technically a hard problem. I mean, in principle, you do the long division and then find the remainder. But I hope that you agree with me, this is not a wise decision, because then probably you have to do it 50 times. Because every time you divide, you reduce the degree by 1. Okay? Do you think that we can answer this in a matter of seconds? And how? So let me give this a name. P of z is this one. Let me call this one B of z. So what type of remainder do you expect? Do you expect a constant term, 0, or what? So I divide P of z by the long division method, for example, by B of z. And then you calculate what do you get at the end. What do you get at the end? You get a quotient here, and you get r. Do you think it's a good idea to write r of z here? Of course, it is not wrong to write r of z, but do you think r involves with z there? No. Why? Do you remember I told you that we continue this process until
0.
two things happens. Either this becomes totally zero, or
You don't have any
it
factors.
becomes, the degree of this becomes less than the degree of this. But because here the degree is 1, the degree less than of it, it should be degree 0. So either it is 0 or any other constant. Okay? Now, can you find a very simple way to find this constant here? So let me write this. P of z becomes equal to Q of z, B of z times Q of z, plus R. So if you don't mind, let me clean this z and write R. And okay. Your target is to find R without having to go through this very, very long division. Can you tell me how? Might be if I write this in place, you can understand it better. The idea is that, yes? The idea, there are two question marks here. This is not a question mark. I know it. I know it. There are two question marks. One here, one here. But this is the one that I want to find, so don't consider it a question mark here. This is your problem. So in order to answer this one, you have to get rid of Q of z, but of course you cannot get rid of it because you don't know what that is. Okay, this is really helpful now, I would say.
You need to find c minus 1 times the quotient should be that expression, but
Okay, practical way, that's not a practical.
it should.
This is equality. Equality between polynomials means what?
Same degree.
No, the same degree is one condition.
Yeah.
But when I say two polynomials are equal at the polynomial level, what does it mean?
The factors of their terms are equal, or whatever, how will we phrase that?
No, I want you to rephrase it in a good way.
Mm-hmm.
Two polynomials are equal if and only if for each assignment to the variables, these two polynomials giving me the same numbers.
Yeah, of course.
Yeah.
Yes.
Mhm.
Okay, so that's it. Okay, finish the problem.
It's,
Anyway, so P of z is a polynomial on the left. It is equal to this polynomial on the right. So it means P of 1 is
Oh, yeah.
equal to, when I replace z with 1 here, it should be the same if I replace z with 1 there, yes? Q of 1 plus R.
yeah.
I don't know Q of 1, but the good news is that I don't need it because 1 minus 1 is 0.
Yeah.
Yes? So this is totally 0. So P of 1 is R. So if I want to find R, I just need to replace z with 1. And calculating P of 1 is extremely simple. So P of 1 is what? 1 to the power 50, 1 minus 2 plus 1 minus 2 plus 1. So what's the answer? 1, 1, 1,
Minus 1.
minus 1. And don't get confused, minus 1 is acceptable here. It's not, don't say that minus cannot be a remainder. That is remainder for integers in Math 5. Is that understandable? Yes or no? Okay. Okay, if you understand that, let me ask you another question. Can you tell me, if I divide this by that one now, what is the remainder? This is a harder problem. So I don't know, this is in the book. If you want, let me write it as a remark. Okay, the remainder, if you want, write it as a remark in your notebook. The remainder of the polynomial P of x by x minus a is equal to, can you tell me? Is equal to what? So you see, you divide P of x by x minus a, you have a quotient and you have a remainder. but the remainder is this constant number here. So how can I find the remainder? I have to put x in a way that I can get rid of it. What x is suitable? A. So R is P of A. So is equal to P of A.
So for this case, there are two choices.
No, but that is a little bit harder because let us just analyze this new problem. So I put a power of 2 here, and then I want to do the same thing here. So I divide it by what? Z squared minus 1. And then I do this process. I get a quotient up there. But I get what? R. Can I write R here? This might depend on Z. Why? Because the degree of this should be less than the degree of this. But less than this means 1 at most. It might happen that yes, coincidentally it becomes 0, coincidentally it becomes 1, but this is not something that I can foresee. So what I can write, this is an RZ, but I know RZ is of first degree. Yes or no? Okay, so it means that in general this is of this type. Okay, then write the P of Z. So P of Z is equal to Z squared minus 1 times Q of Z. I don't have any access to Q of Z at all, but I know something about the remainder. I know that the remainder is in general a first degree polynomial. When I say in general it's a first degree polynomial, it means that I have to find 2 unknowns now. Okay? Well, now can you tell me what to do?
0.
P0 is not good. Why you say P0? Because when you put 0 here, it becomes minus 1 times Q of 0. Do I have access to Q of 0? No. If I want to have access to Q of 0, I have to do the
You
division.
try for 1
1
and minus 1.
and minus. Yes? So I put P of 1 is equal to 0 times A plus B, and I write P minus 1. It is minus 1 to power 2 minus 1 Q of minus 1 minus A plus B. Agree? But then, do I need to be worried about these two? No, because this next factor is 0. This is also 0. So this is totally 0. This is totally 0. P of 1. What was P of 1? I have to put 1 there. What was the answer? Do you remember? P of 1 was minus 1. So P of 1 is minus 1 is equal to A plus B. P of minus 1, then I have to put it there. Minus 1 to power 50 is still 1. Plus 2, plus 1, plus 2, plus 1. So if I haven't done it wrong,
7.
so it becomes 7. So it means that minus A plus B is 7. And then I solve the system. I add them. So B becomes 3, B becomes 3, A becomes minus 4. But the answer to the problem is what? The remainder. So the remainder is AZ plus B. So it is minus 4Z plus 3. So that's also a very good technique to learn. Okay? Let me give you a little bit more complicated. We are done. So let me take this one, and this is more interesting. But this is very big, so I cannot work with that high power. But let me make it to power of 4. And then this time I will give you Z squared and minus Z plus 1. My question is that, can you find the remainder of this by this? Without, of course, the long division. By long division, you always can find. This is a little bit harder to understand. I hope that I can explain it to you. Because there is no time, let me explain. So what we do, we take that polynomial, P of Z, and I divide it by this. I know that I will have a quotient, but what is my remainder now?
Same form. So A, C plus B.
So let me write the remainder R of Z. Okay. But what is, my question is that, now what I want to tell you is that this polynomial is equal to this polynomial. So whatever I do to this polynomial, If I do the same thing to this polynomial, the answers will be the same. Is that right? So this polynomial is equal to this polynomial. So whatever I do to this polynomial and do the same thing to this polynomial, the answer should be still the same. Okay? Now the interesting thing, I want to change this to z minus 1 in that polynomial. Okay? Okay, so this means that I want to do this transformation here. You might don't understand the logic, but you will in a moment. I am telling you, go to this polynomial, replace every appearance of z squared with z minus 1. What should I do with z? Leave it alone. So I want to change z squared to z minus 1, but I want to keep the z's the same. Now let us see what happens on the right-hand side. Because if I do the transformation like that on the left-hand side, and if I do the same transformation here, still the answer should be the same because they are essentially the same polynomials. Okay, but can you tell me what happens to the right-hand side if I do this substitution?
Thing becomes 0.
This thing becomes again 0. Instead of z squared, I put z minus 1. These things become 0. But the good news is that, do I need to be worried about this? There is no z squared here. Why? Because the degree should be less than 1. So there is no z squared that I have to be worried about. So what is left for me is just rz. So it means that go to your polynomial, change z squared with z minus 1. And that will be your remainder. So what I have to do here, I will go and write everything in terms of z squared. So this becomes z squared squared minus 2zz squared plus z squared minus 2z plus 1. And whenever I see z squared, I replace it with z minus 1. In a matter of seconds, the lesson is finished, but just wait a little bit, please. Okay, so then I raise it to power 2. So this is z minus 1 squared, so it becomes z squared minus 2z plus 1. Z squared is z minus 1, so it becomes minus 2z. I multiplied it, yes? So let me write. Okay, let me write it for you. Okay, so this becomes z minus 1 squared plus 2z, z minus 1, and then I have plus z minus 1 minus 2z plus 1. Then I raise it to power 2, z squared minus 2z plus 1. You might say that this is not shorter, but it is. We can design questions that this become much shorter. Okay, so then what happens? This becomes 3z squared, but instead of z squared, you again put z minus 1. And this one and that one minus 4, minus 6, and minus 5. Yes? And then 1 are gone, so I get 1. And then you multiply. So 3z minus 5z is minus 2z, minus 3 plus 1 is minus 2. So that will be your remainder. Yes? The idea is beautiful, but I did it very fast because we don't have time. But you can do it yourself. You can make some stories yourself and see that you can learn this one. I hope that I haven't done any mistakes there, but this is the idea. Any questions? Okay, have a nice weekend. Thank you.